All right. Um, yeah, thanks for joining everyone. As usual, I know always have the late shift, so uh, I appreciate everyone joining, and I hope you um, this adds some value to your revision. All right, so today we're gonna cover probabilities, and this is quite an interesting topic. It kind of gives you some sort of understanding, in a way, how gambling works, expected odds, um, expected value, in other words, the average based on probabilities and what exactly a probability means. All right, so let me share my screen, kind of put things in context here. Here we go. Okay, just give me a heads up if you can see the whiteboard. I'm gonna scribble here for a bit. Tell me if you can see that before I start. Cool, perfect. All right. So probability, right? You may have heard of it. You'll see it in weather reports. When they say there's a 30% chance of rain, 70% chance of rain. Those are probabilities, and everyone can kind of guess that the higher the probability, then the more likely something is to occur. Like if they say you got a 70% chance of rain, you pretty much know that it's most likely going to rain versus like a 20% chance of rain. All right. So generally, probabilities are expressed as percent, but they can be expressed as decimals. But you'll never find a probability less than zero. So that means you'll never find a negative probability, and neither will you find a probability greater than one or greater than 100%. Okay, so it's bound by those limits. It can be as low as 0% and as at most 100%. But what exactly does it mean? Okay, so let's say if you flip a coin, right? Let me ask you this. What is the chance of me getting a head on the flip of the coin? So remember, the coin only has head and tails. So what is the percent that I could get a head when I flip that coin? Give me the percent, you give me the fraction. So is it 1 over 4? Is it 1 over 2? Is it 20%? Is it 30%? Is it 50%? Let's see what anyone wrote. Yes, exactly. It's 1 over 2, right? Now, instinctively, many of you can just see that because there's only two possible outcomes, which is why you have that denominator of 2, okay? The value in the bottom of that fraction is 2. There's only two possible outcomes, and only one of those outcomes is a head. But if we know that the probability of getting a head, right? So we know the probability of getting a head in the flip of a coin. If we know that this is a half, right? So in other words, it says, and you may have heard this before, out of every two flips, you're likely to get one heads, right? So let's say I flipped this coin the first time and I got a tail. So that's already one flip. So now here's my second flip. So if that probability is 1 over 2, shouldn't the next flip be a head? Because one out of those two flips should be a head. Unfortunately, probabilities don't work that precisely. And this is what you need to take away from what a probability means. We don't know that the next flip, even though it's the second flip, it's going to be a head, given that this is the probability. This probability works when you have a large number of experiments, okay? That's when this probability tends to go to the value that you see here. In other words, if I flip this coin 10,000 times, I'm gonna and let's say it was 10,000 flips that I did, you're very likely to find that out of those 10,000, a number very close to 5,000. I'm going to use this symbol here for approximately. So approximately 5,000. You may not be exact. It could be like something like 5,920. I'm making up this number, but it's pretty close to this, right? If you do 10,000 flips, then almost half of it will be 50%. So probabilities don't work for a small number of trials. They work when you have an extremely large number of trials. And the larger those trials or experiments, the closer it tends to that probability exactly. The number gets closer and closer to half. Okay, so that's how probability actually works. It works on based on a large number of experiments, and that's how basically if you look at a casino, that's how it works. Okay, so if you know that if there's a table where you roll a die, and let's say the die, it's only one die. Okay, so it's you can only have the numbers 1, 2, 3, 4, 5, 6 when you roll the die. When you roll the die, you can only have 6 numbers, and um, the casino bases the payouts on a large number of trials, and it's okay for them to do that because it's not only going to be you that's gambling there. After you leave, there's going to be someone else that occupies the table, and then so on and so on. So in the entire day, they have quite a large number of trials, so they can base these probabilities. They can use these probabilities because they do have a large number of experiments happening, and that's how they can work out the payouts, etc. Does that make sense? Okay, how probabilities work and the large number of trials. Does that make sense? You won't be tested on this, but I'm just kind of explaining it to you to out of interest basically, and how probabilities actually work. All good? If I get one thumbs up, I'm happy. But like I said, you're not tested on that, but it's just to give you context of how probabilities.
Sorry.
Is that Victor?
Sorry, can I ask you something? I understand
Yeah,
what you're
sure,
trying to
go for it.
say, but it's also possible, let's say, if you have like a very large number of trials, like for example, you flipping that coin 10,000 times. I know it might be strange, but there's still a possibility that maybe you'd have all tails. Am I right?
Yes, it is a possibility. Absolutely right. It is, but it is extremely unlikely. So you're absolutely right, but it's very similar to when they say if you're swimming, what's the odds of you getting struck by a coconut and dying? It can happen, but it's extremely unlikely. So it's the exact same thing what you're saying. You can have the case where everything is a tail, but that number is so small. It's virtually 0%. Does that make sense?
Yes, yes, it does. I get what you're saying.
Okay, cool. And it's kind of the same thing for people playing lotto. If you maybe at the end of this lesson, you might even be able to work out the probability of winning the lotto. To realize how small those odds are, but people do win, but the odds are actually really small. Um, okay, yeah, good question, Victor. Um, all right, so let's move on. Okay, so this is the kind of typical question you can get asked on probabilities. Okay, so I'm just going to clear this, and I'm going to share some data in the table because that's how you'll be presented um, the information to answer these questions. So I'm just going to copy this, and I'll explain this in a second. Okay, can everyone see this table? Is it clear? Give me a heads up. There's the rows are directors, managers, junior, and the column mining and finance. Great. All right. So this is called a cross-tabulation table. Okay, when I say cross-tabulation, it's basically tabulating two different variables. On the columns, you have the different industrial sectors, that is the mining and the finance. And on the rows is another variable, which is basically your position in the companies. So you can either be a director, a manager, or a junior. Right, so it's two variables: position in the company versus industry sector. All right. So that, and if you how we read the numbers in this table is if you look at the number 21 on the first row and the first column, that's telling you that we have 21 directors in the mining sector, right? And if you look at the bottom rows where it's shaded, those are your totals. So if we add up everyone in the mining sector, that is 21, 80, 210, you'll get 311. So that means there's 311 people in the mining sector, and so on. Directors, we have a total of 61 directors. Altogether, we have 751. So if you add up all the numbers inside this table, 21, 40, 80, 160, 210, and 240, you add them up, you'll get 751 staff in total, right? So that's your grand total is 751. Now, when you're given a cross-tabulation table, you're likely not going to be given these totals, okay? You have to work them out, okay? That's something you'll have to do, but you will need them. So let's say the typical kind of question that you can get based on this data is they could ask you, based on this information, what is the probability of being a director? So I'm going to write your probability of director. So instead of writing the whole word director, I'm just going to write DIR, okay? Just know that that is director. So how you work that out is, for any probability, and just like how you did the heads, the probability of getting a heads, what you're doing is you're actually working out the number in your numerator. It's the number of events of interest. That's the number of events of interest. So in our case, it was heads. How many events can you have a head? And there's only one event where it's a head. So of interest. Sorry, I'm just gonna. Oops, my bad. Okay, so I'm just gonna write your interest. Events of interest divided by the total number of outcomes. So all possible events. So the number of all possible events. That's how you work out a probability. And that's exactly what you did for the working on the probability of heads. So if you want the probability of a director, you basically look at what the numerator is, which is the number of events of interest, which is directors. How many directors do we have? And that is 61. We have 61 directors. Okay, that's the total there. And the total number of events is basically how many people in total do we have? And that's 751. And as a guideline, please express your probabilities as a percent, and remember, aim for 2 decimal places. So for this, if you punch it into your calculator, you should get 8.12%. 8.12%. And note, please, when you calculate these in your assignment and in your exam, provide an interpretation. All you need to say is the probability of being a director is 8.12%. That's about it. Okay, very, very simple. If you don't, you lose a mark for that. So just a heads up, provide an explanation or interpretation, so I say. So I showed you how to work out the probability of a director. Now I want you to apply the same methodology, and I want you to work out what is the probability of being in the finance sector. So I'm going to write it like this: probability of being in the finance sector, FIN. Can you work that out for me and tell me what you get? Put it into the chat. Use the same approach that I did for this. I want you to work out the probability of being in the finance sector. And remember to put it as a percent, 2 decimal places. Give it a shot. It doesn't matter if you get it wrong. This is the time to actually get it wrong and learn from it. Okay. Wait for more students to put their value in. Okay, so now you're working on the number of people in the finance sector divided by the total number of people. Anyone else? Okay. If you did it, you should get 58.59%. Okay, so remember your numerator would be how many people in the finance sector, which is 440, divided by the total number of people, which is 751. And if you express that as a percent, you should have 58.59%. Okay, so it's pretty simple how to work out these individual probabilities, but you'll also be expected to work out joint probabilities. And a joint probability is basically an intersection, or a fancy way of saying and. Okay, two events intersecting or occurring together. So in other words, let me give you an example to put in perspective. Let's say I've been asked to work out the probability of being a manager in the finance sector. In other words, being a manager, I'm just going to write, okay, I'm going to write the whole word, any manager and being in the finance sector. This is what I've been asked. Okay, so here it's very similar to how this principle still holds. Okay, what the numerator is, it's basically how many managers do you have in the finance sector. So where do they intersect in this table? So if you, here's the finance column. If you go down and you look at where managers are, which is in the second row, where do they intersect? They intersect at 160. So that's your numerator. It's 160 divided by the total. The denominator is still the same. It's 751. Okay, and you can work this out as a percent. You should get 21.3%. All right, and then provide an interpretation. So you would say the probability of being a manager in the finance sector is 21.3%. Okay, so that's a joint probability. Another symbol for and is this symbol here, intersection. It's like an upside down U. Okay, just know that that means the same thing. All right, and now that you know how to work with individual probabilities like here, here, and you know how to work with the joint probability, it's time to move on to what we call using the addition rule. In other words, working out the union of two events. And the union of two events is just a fancy way of saying the probability of something or something happening. All right. So you'll have this formula given to you. You don't need to memorize it, but I'm going to write it down here anyway. It's the probability of A union, which is like this U, B, and just think of U as the word or. It's the same thing. So the probability of A or B happening is equal to probability of A plus the probability of B minus the probability of A and B. And I'm just going to start using the symbol here for and now. A and B. All right, so you don't need to memorize this. It's given to you, but I'm going to show you how you use it in practice. Okay, so now you're asked to work out what is the probability of being a director. So you ask, what is the probability of being a director? Director or being in the finance sector. And write DIR for director and FIN for finance sector. So now instead of A and B, I have this as my A and this as my B. So it's just a matter of substituting director for A and finance for B in this formula here. And you can work it out. So the first part is probability. So all I'm doing is I'm using this equation now. Okay, and instead of A and B, I'm using director and finance. So it's the probability of director, DIR, plus probability of being in the finance sector, minus, and I just don't have any spaces, I'm going to write in the next line, probability of being a director and, or intersection, being in the finance sector. And we've actually worked all these values out. We did this earlier here. There it is. It's 8.12%. We did all the hard work. Probability of the finance, of being in finance, we did that already as well. Here it is here. And then probability of being a director and being in the finance sector, we haven't done that as yet. But that is simply just, you follow the same approach that I did here. So let's just work this out. So the first part is probability of a director is 8.12%. Plus probability being in the finance sector. If you work this out and got a decimal percentage, I think it was 58 point something. Just give me a second. Yeah, 58.59% plus 58.59%. Okay, and then the last part, which is the intersection, this joint probability, we look at how many people are directors in the finance sector, and that is 40 people. So we have 40 people here out of 751. Okay, and if you punch this entire equation into your calculator, you'll get a value of 61.38%. Okay, if you work that out, you should get 61.38%. 61.38%, and then provide an interpretation. Okay, so I'll just pause there for a second. Does everyone follow how to use this equation here, the addition rule? You use it when you're asked to work out the probability of something or something occurring. Okay. So if there's anyone that want me to explain this again, or if there's anything that you're uncertain about, just let me know in the chat, or just unmute and let me know, and I'll go over it again. Otherwise, I'm going to move on to the next part. All good? Cool, cool, awesome. Thanks, everyone. All right. The next type of probability you need to know is conditional probability. Okay, so all that actually is when you ask to work out the probability of something given something has occurred. All right, so let me explain that by an example. Almost done. Bear with me. There you go. Okay. All right, so I'm just going to write the value out here because I'm going to use the probability again. Finance sector is 58.59%. 58.59%. All right. So let's say we're asked to work out what is the probability of being a director, right, DIR, given. Now the mathematical symbol for given is this vertical line here. Okay, so that's given that you're coming from the finance sector. Okay, I'll write the full word. All right, now the formula for this, now this formula is given to you. You don't have to memorize it. You just need to understand when to use it. This is when you're told the probability of A given B has occurred is equal to the probability of A and B divided by the denominator is always whatever's on the right of the vertical line. So it's B. Okay, this is the formula you use. So in our case, this is our A, director, and finance is our B. All right, just going to use that formula here to answer the question. So the numerator is the probability of being a director, and I'll use the symbol intersection again to save space. So writing and being in the finance sector divided by, okay, the probability of being in the finance sector. All right, and I've showed you how to work this out earlier, that the numerator is simply, let me just make some space here. Okay, the numerator is, you basically look at how many directors you have in the finance sector, which is 40. So it's 40 over 751. That's our numerator. And then the denominator is probability of finance, which is here. It's given to us. We did it earlier. 58.59% divided by 58.59%. If you punch this into your calculator, if you do use your calculator, use the brackets, okay? It's telling you, you're telling the calculator to work this out first and then divide by the denominator, okay? So you're kind of using BOMDAS procedure. If you work this out, okay, I haven't done it, but you can work it on your calculator as an exercise. But this is the method to actually do it. I should give you this value if you want. 40 over 71, second, to 41 divided by 58.59. I think you should get a value of like 9%. Yeah, like 9.09%. That's what you should get here. All right, so that's how you work at conditional probability. You use this formula here, okay? And you should get a value of 9.09%. You can work that out now if you want, just to double check it and to see that you're okay with using your calculator. But does this make sense, how to work at conditional probabilities? So these are what you can be asked for probabilities, okay? You can be asked to work with the probability of a single event like here. You can also be asked to work with the joint probability. So basically something and something. So like what you have here in this numerator. So both of them occurring together. You can also be asked the probability of something or something happening. In other words, using the union rule. So the probability union B, you can be asked that, which you did earlier. And lastly, you can be asked for the conditional probability, which is this probability of A given that B has occurred. Okay, is everyone okay with that? Are you comfortable using those formulas and how to use them? This is a typical kind of question you can get using a cross tabulation table. And it's important that you know how to pull the values from this table in order to work out the probabilities. I'll just pause for a second just to see that everyone's okay, if they need to go over something. Thanks, Victor. Is the silence that everyone's okay? We're all good? Or would you like me to go over something again? Okay. All right. So we're going to move on lastly to counting techniques. All right. Now, let me just open a new whiteboard. Okay, so counting techniques is basically if you're counting the number of ways you can arrange something. All right, so let's say I had, let me put this, I'll copy and paste it because it's easier. As an example. All right, so let's say you had 3 letters, okay? And you can think of each letter as someone, a person. I had 3 people and I want to arrange them in different ways, okay? So the one way I can arrange them is person A, B, then C. Then I can also make an arrangement of A, C, and B, then BAC, BCA, etc., all the way to CBA. And these are all possible arrangements. Okay, there's nothing else that's missed out. If you have 3 people or 3 letters, these are the different ways that you can arrange them. All right. Now it's easy when it's just like 3 items and you want to arrange it, but it becomes a lot more complicated when the number increases. When you got 5 people or 5 things, 5 cars, um, anything that you want to arrange, as the number becomes higher, to actually write out all the possible arrangements is not easy. And you may not even be interested in actually knowing each arrangement. All you want to know is how many arrangements are there. So in this example, there's 6 arrangements, okay, because I can actually write them out visually and see them, right? so you can actually count them just by writing all of it out. But as I said, when you increase that number, it becomes a lot more difficult. So the general rule, okay, so now here, what happens is you need to ask yourself one thing, okay? Like, look, here the order matters. If I have A, B, C, it matters that the arrangement is different, okay? So how you work that out is you use something called permutations, all right? In your calculator, and if you have the Casio calculator, it's basically using what you see above your multiplication button, which is NPR. NPR. So if you look at your calculator and you look on the multiplication button above it, you will see something that says NPR. Okay, so you're basically looking at how many different arrangements you can have of for three numbers. So if you wanted to actually work that out, you would use this permutation to actually calculate it. Now, what this actually means, there's an n before it. The n is how many items do you have in total? Well, there's three items. There's A. So let me just use my pen instead. Okay, the n is how many items you have in total. So that is A, which is 1, B, which is 2, and C, which is 3. So you have your n is 3 here. Okay, and you want to use all of them to determine the possible arrangement. So your R is basically how many out of those three are you selecting? Well, in this case, you're selecting all three of them, all right? A, B, and C. So your R is 3. Let me just give you another example to kind of understand it differently. Let's say I still had the three letters, A, B, and C. Okay, so our N is 3, okay? But instead of taking all of them, I want to see how many possible arrangements I can have by just taking 2 of them. So that means I could have A and B, I could have B and A, I could have C and A, C and B, and you can see where I'm going with this. Okay, so I haven't taken all of them. I've only taken 2 out of those 3. So here your R is 2. That's what your R is. How many, what is the subset? Or how many are you selecting out of the entire sample? I'm only taking 2. So if I want to know how many possible arrangements there are by taking 2 of them out of the 3, where the order matters, that means it doesn't matter if A is first and B is first, but the items are the same, this order matters to me. Then you would use permutations, the NPR. So in other words, we're going to work out 3, P, 2. And how you work that out is, with your calculator, you're going to type 3 first. So you'll type 3, all right? Then you'll press Shift. You will press the multiplication button because that's where your NPR is, all right? And then you will see in your calculator on the display, a P will pop up. And now your R is, as I told you, you're only selecting 2. So you will type 2, and then you'll hit equals to, and you will see that there's 6. There's 6 possible arrangements. Okay, does that make sense? How to use permutations? Okay, so let's say, for instance, another example, we had let me go to the chat. Thanks, Marty. Thank you. All right, here's another example. All right, so something a bit more practical and real world. Let me give you 5 people. All right, John, Cindy, Joel, Bob, one more person, Sam. Okay, there's 5 of them. All right, and they're competing in a test. All right, so let's say they're writing a class test, and the thing is, they're going to get awards. You're only going to get an award if you come out first, right? If you come out second, and you come out third. All right. Now, the question is, in how many different ways can we have podium positions? Now, you think about it, the order does matter, because even though I may have a selection of John, right, coming out first, Cindy coming out second, and let's say Sam comes out third, right? This is, even though I take the same three people, so if I have Sam first, John second, right, and Cindy coming out third, they're the same three people, but this order does matter because their positions are different. Okay, this case Sam came out first, whereas this case John came out first. So now the question is, how many different ways can we have podium positions? And this is where you use permutations. So that means here n is 5 because you have 5 people. So to work that out, you would type 5, right? Then we'll press shift, and then you'll use the NPR button, which is the multiplication button. So you have 5p, and then we're selecting how many out of them. We're selecting 3 people, podium positions. And then you hit equals to, and you'll get, that's the number of arrangements that you can have. And if you hit equals to, you should get, so I'm doing my calculator correctly, should p 60. You can have 60 different arrangements. See, so you can see that you can't write out 60 different arrangements. It'll take you quite a while. You'll even overlook certain ones if you had to do it. This is where permutations come in. Okay, it will give you that number of arrangements. All right, I hope that makes sense to you. Permutations are when the order matters. Okay, now you're also going to have something called combinations. So in your calculator, you'll see next to the multiplication button, the division button, above that you have NCR. Now that is when the order doesn't matter. So that means if I have this arrangement here where John, Cindy, and Sam place first, second, third, and if I have Sam, John, and Cindy, I don't care that their order is different. Okay, they're the same 3 people, so I'll count this as 1. This is when you're going to use NCR. All right, so when the order doesn't matter, you use combinations. You use this. When the order does matter, you use NPR. Okay, so remember that. That's how you identify when to use which. All right. So let me give you an example of using combinations. Very, very simple example. Some of us might be familiar with. Maybe let's go to using the lotto, but I'm going to simplify it and just take fewer numbers because it'll be too big a number to calculate. Okay, so I haven't played the lotto in quite a while. I think last time I checked it was like 6 numbers or something. But let's just make this a bit easier. All right. Almost done. Okay. Let's just say a game very similar to the lotto is you select 6 numbers. Okay, you select 6 numbers. 1, 2, 3, 4, 5, 6. Okay, you can select 6 numbers. And the numbers you can choose range from 1 to all the way. I can't remember what the lotto numbers go up to. Let's just make it 30 to make things a bit easier. So you can select numbers 1. Sorry, my bad. Check the chat. I'm not sure, Stefan. As soon as I get a heads up from the lead OT, I will let you know. I'll send out an announcement. Okay. All right. So now the thing is, I'm going to make a bit of an exception for this game. Okay. In the lotto, you can repeat numbers. So that means you can select 2 here and you could select 2 again. Right. But in this case, I'm going to say no, you can't repeat the number. So you can only select the number once. Okay. Once you select it, it's crossed out from here. So now you're selecting 6 numbers. All right. You're selecting 6 out of 30 numbers. All right, so that means your n is 30. Oops, 30. And your r is 6. All right. So the question is, how many different arrangements can I have? Now, so remember, if you had chosen, let's say the winning numbers were this. Say it was 2, 30, 1, 5, 6, and 4. Say these were the numbers, the winning numbers. You would still win if the order was different, right? Remember, if you had 30 first, and you had 2 second, and 5, and you had 1, 6, and 4, even though the order is different, you would still win. Okay, as long as you have those 6 numbers. And remember, I did say this, I'm making an exception for this one, is that you can't repeat the numbers, right? So it's a bit of a different story here. That changes things a bit. So don't worry about that. So now you know that the order doesn't matter. So immediately you should be using NCR, not P, because the order doesn't matter. So if you want to work out how many different ways you can select 6 numbers out of 30, you would work this out in your calculator. 30, which is your N, C, and then your R is 6. And if you work that out, what number do you get? So I'm going to check that you're using your calculator correctly. Work this out in your calculator. 30, C is 6. So how many different arrangements can you have? Yes, it's quite a large number. So it's like 590,000 arrangements, right? I'm just going to put something in perspective here so you kind of get the idea. So 590, 3,775. Now, in this example, I gave you fewer numbers than what the lotto actually allows you. I think the lotto numbers go over 40, I think. And also the lotto allows you to repeat numbers. You can repeat numbers. And when you repeat numbers, this number goes up. It actually goes higher. You can have different, a lot more arrangements. All right, so this number gets much larger and larger. Now, these are the total number of arrangements that you can have when you're selecting 6 numbers. So my question to you is if these are the total number of arrangements that you can have, then what is the probability that you could win this game, this uh, lotto-like game? What is the probability that you could win it? Not a bad guess, not a bad guess. Sorry. So remember, these are the total number of arrangements, but you already took into account that there's no repeats, all right? So if you're selecting, sorry, you know what, Victor, give me a second. That's a bad question because you actually didn't work out the denominator. That's fine. Okay, ignore that question about the probability. It's basically, it is going to be a small number. It's 1 divided by this. Yeah, that's pretty much it. You got 1 chance out of all of this to actually win it. But actually the takeaway for this is just, I'd rather you focus on just how to get the number of arrangements when the order doesn't matter and when the order does matter. Does everyone follow the permutations and combinations? How to distinguish which one to use? And just sort of just as you may be interested in what's the chance of winning, it's actually 1 out of this number here, which is quite small. Thanks, Caroline. Everyone, we're all good? That's pretty much what I wanted to cover today. I wanted to cover probabilities and counting techniques, which is what we finished off here.
So for the commutations and the permutations, so we use this here, but like it's only for data that you can't repeat the same number, right? As you said.
Yes. If you can repeat, then it changes things a bit.
Okay,
Because
then it's not.
yeah. So basically, this arrangement here, like you see here, you could actually have A, and A again. And that changes things, because then you could have a lot more arrangements. You can see that A is not included here. But if it was, that means you're allowing repetitions, then you'd have a lot more arrangements. But you won't be tested on that. Repetitions are not part of this course. But just know that if there is repetitions, that does change the number of arrangements that you can have. Does it make sense?
Yes. And also something I missed. So when you were doing that ABC and ACB, then
Yeah.
you put the R value as 2, but I'm thinking that the R value is 3.
For this one, yes. For this, it's 3P3, right? But if I was only choosing 2 out of those 3 letters, that means if I'm only interested in arrangements of 2 of those letters, so AB, BA, CA, CB, AC, etc. Now I'm only taking 2 out of those 3 letters. So that means your R is 2, but your N is still 3. Because there's 3 possible letters, A, B, and C, but I'm only selecting 2 at a time. Does it make sense?
I see. Yes, makes sense.
Cool. All right. That is it from my side, everyone. And Stephen, does that answer your question about the NSS? And I'm assuming you meant for assignment 2, not task 2, right? Welcome. And please, as a heads up, get going with the ICE tasks. You've actually covered all the learning units you need to do the ICE tasks. So don't wait for the last minute. They're all available to you, so give it a bash. All right. Any questions? Yeah, you can always drop me an email. Otherwise, thanks for joining, everyone, and have a wonderful evening.
You too, so have a good evening.
Yeah, Marty, your question is ICE tasks. There's 4 ICE tasks, and there's ICE tasks 3 and 4. 4. No, it's not even 4. Oh, you're talking about assignment. Oh, assignment. I'm not sure, Marty. Let me just see if I can find that in the module outline. So I'm just opening up the module outline and checking. Assignment 2. It's learning in 3, 4, and 5. So yeah, so like I said, it's more learning units than what your assignment 1 was. Your assignment 1 is only 1 and 2. The next one is going to have 3 learning units, 3, 4, and 5. You're welcome. All right, all. If there's anything else, enjoy your evening. We'll chat soon. Take care.